Okay, so we're going to finish off with some circles and some circle rules and circle theorems. So looking at some keywords, again, most of these should be fairly familiar to us. Radius, obviously the line from the center to any point in the circle. A chord is any line segment that joins 2 points in a circle. The diameter then is the chord that goes through the center. So we can be familiar with what the diameter is. It's twice the radius. Circumference is the perimeter or the length of the circle, so sometimes it's called the length of the circle. Arc is any point in the circumference. Sector is a section of the circle between two radii, and the tangent then is a line that touches the circle at one point only. So again, all of these words we should be fairly familiar with. Looking at some of our circle theorems, then some of our rules that we need to know of, that we kind of need to know so that we can use them, not necessarily that we need to be able to state them back. So the first one is that the angle in a semicircle is a right angle. And what we mean by that is if I have a circle and I draw a triangle within that circle, which has the diameter as one of the sides, okay, so it has to go through the center, it has to have the diameter as one of the sides, then that means that this angle up here, where it touches the top of the circle, will be 90 degrees. So for any triangle which is sitting on the diameter, or which has the diameter as one of its sides, then the angle at the top of the triangle that it makes when it touches the circle will be 90 degrees. Your second rule then is if I have a tangent, the tangent to the circle is perpendicular to the radius where it meets the circle, okay, at the point of contact. So when we have my tangent, it's going to be perpendicular or right angle to the radius at that point. My next one then is if I have two circles and if they intersect at just one point, so if they just touch each other, if the two circles just touch at one point, then the two centers and that point where they intersect with each other are going to be collinear. And that means we can draw a straight line through those 3 points. And we can see here I've just put down two different ways that that can happen. So if a circle touches another circle at one point, they either touch externally or they touch what we'd say internally, where one of the circles is inside the other. But it just means we can draw a straight line through the 2 points where they meet, or through the two centers and the point where they meet. Then the last theorem, or the last rule to know, is that the perpendicular from the center to a chord, remember that a chord was any line that connects 2 points on the circle, so it's any line from one side to the other side. If I draw a perpendicular line from the center to that chord, then it bisects it, then it will cut it in half. So if it's perpendicular, it will cut the chord in half. So that second part, I suppose that theorem there can be used sometimes to find the center of a circle. So this is kind of where we kind of have to adjust sometimes how we use these rules. But we'll look at an example to see how this kind of comes into play. And this is one working with a chord. So we're told AB is the diameter, so it goes through the center. CD is a chord with a midpoint of M. AB is perpendicular to CD, so that's my line. AB is perpendicular to CD, so we're going to have to use my last theorem there, and that's kind of what's drawn in here. So we're cutting at a right angle. CD is 8 centimeters. And if CD is 8 centimeters, that means that this is 4 and this is 4. Okay, and we can write that down. So we're looking for OC first of all. So I'm going to say first of all that CM is equal to 4 centimeters, and that's coming from my previous rule. So the chord, the perpendicular from the center to the chord bisects the chord. Okay, so that's going to be 4 centimeters. If I take this part that I'm looking for, so I'm looking for OC, I know that this is 4, and I also know that this is 3, because I'm told OM is 3 centimeters. So I can use Pythagoras. So OC squared is CM squared plus OM squared. So 4 squared plus 3 squared. And this should be one that we are kind of familiar with as well. So 25, which means that OC is going to be 5 centimeters. So OC is 5 centimeters. Looking for AM then, well, first of all, we should note that AO is the radius of the circle, and that would be the same as OB. Okay, now are we given the radius of the circle at any point here? We're actually not given that radius of the circle. So we're going to have to use some of these other parts that we know, some of these other aspects, some of these other things, or kind of work around it in that way. So we're looking to find AM, this full line AM. Now we know that We know that OM is 3, so if we can find the radius, we're just going to be adding on that 3 to that. We know what OC is. Okay, so that might come in handy for us in terms of working out what am I talking about? OC is the radius. Nonsense. Okay. Sometimes it's good to just show you me thinking. Okay, just to show my train of thought. OC is my radius, okay, and this is where my diagrams help. So when we draw that in, OC is going to be my radius, which would be the same as OA. Okay, so that's why they're leading you through finding that in the first part. So if that's my radius, that means that AM is going to be OA plus OM. Okay, so my radius we got was 5, OM was 3, so that means that that is 8 centimeters in total. Okay, flubbing it a bit, but we're grand. So yeah, so OC was my radius there, and spotting that I suppose was the main thing. So it's always good to write in these things. Looking then for MB as my last part here. So MB is this part, this line here. Now again, OB is the full radius. So OB is the radius, which we've established is 5. So 5 take away OM, which was 3, gives me a value of 2 centimeters. So that means that MB is 2 centimeters. And lastly, we're going to look for AC. Now we can draw out the triangle here again. So this is A, this is C, this is M. Okay, we know AM from the first part is 8. We know CM is 4. We know this is a right angle. So again, AC squared is MC or CM squared plus AM squared. Subbing in my different values, this is 4 squared, this is 8 squared, so 16 plus 64, so 80, which means that AC is the square root of 80, and we can work that out using our calculator to be 4 root 5 centimeters, and we're not actually asked to give it in terms of decimals or anything like that, so we can leave it as it is, 4 root 5 centimeters. Now we're going to look at a few exam questions just to see those in practice again, or sorry, another example, and then we'll look at some exam questions. So an example this time looking at the tangent and the semicircle on the tangent. The first one we're asked to find is PQR. PQR is going to be 90 degrees, and that's because of the angle on the semicircle. And that's the one we were talking about earlier, where this line is going through the diameter, so that means that this angle up the top here will be 90 degrees where it touches the circle. Looking then for P or Q, so P or Q is this one here that I've marked in black, and what we should know from earlier is that this angle here is going to be 90 degrees, and the reason for that is that the radius is perpendicular to the tangent where they meet. So the radius of my circle will be perpendicular to the tangent, and here the radius is OR, so my radius will be perpendicular to this tangent line. Now, how do we use that? Well, we can say that the angle we're looking for, which is P or Q, plus the 57 that we're given, should be equal to 90, and that means that P or Q is equal to 90 take away 57, which gives me an answer of 33 degrees. Lastly, then we want to find QPR, which is this one here, QPR, and we can simply do then that QPR plus my 33 plus the 90 should be 180, which means that QPR is equal to 57 degrees. Okay, and the only other way we could kind of come up with that one is kind of similar to our exterior as we had before. But yeah, so working it out that way, adding up the angles that we have in the triangle, as we've kind of always done, and then taking that away from your 180 to get the last angle there. Looking at your exam questions then, Q, Y, or X, Y, Z. X, Y, Z. In the diagram, O is the centre of the circle S. Find the value of alpha and the value of beta. Okay, I'm not sure what X, Y, Z. X, Y, W, I presume. Let's change that. Okay, so we'll work with the one we have. So this is the centre of our circle, and we want to find the value of alpha and the value of beta. So we have a few different kind of aspects to work out here. Now, one of the first things we're going to have to look at, and this is something that comes up in a lot of questions, is the radius of a circle. So the radius of a circle is the point from any point from the center of the circle out to any point on the edge of the circle. And we saw this in the example that I was talking through there. But if I go from the center here, that makes this line, OW, a radius of my circle. It also makes OY a radius of my circle. And similarly, OX will also be a radius of my circle. So I have that those three sides are going to be equal. And that can be important when we're looking at different aspects of this diagram. So if we focus on this yellow part here, this triangle that I've shaded in yellow, if those two sides are equal, so we can kind of make note of that. So OW is equal to OY, and that's because they're radii. And what that means for me is that the angle OWY is equal to the angle OYW. And that means that, and that of course means then that alpha is 52 degrees. So alpha is going to be 52 degrees, and that's because they're both radii. So we can say then that they have to be the same. Okay, so they have to be the same as each other. Then to answer for the second part, we have a few different ways. What we might use is we'll use that this green angle here has to be 90 degrees. Okay, so that's that the angle WYX has to be equal to 90 degrees. And why is that? Well, it was called angle on a semicircle. It was called the angle on a semicircle. So that was the one where the triangle on the diameter, then that means that the angle up the top of the circle will be a value of 90 degrees. And that means that 52 plus 90 plus 2 beta has to be 180, because again it's a full triangle. So I can take those away from 180, so minus my 90 minus my 52, I get 38, and I get then that beta is divide that by 2, which gives me 19 degrees. So my two values, alpha 52, beta 19 degrees. So we'll finish off with one last exam question then. So in this diagram, the line L is a tangent to the circle. Okay, so we're thinking tangent. We know tangent's perpendicular to the radius, so that's probably going to be important. We want to find the values of x, y, and z. So tangent is perpendicular to radius. That means that these two angles here are 90 degrees. Again, that's probably going to come in important for us. The other thing that we can note here is if I draw this triangle is going through the center. Okay, so my triangle it's sitting on the diameter, which means that my angle up here in the top, my angle x is going to be 90 degrees, and again, same rule, angle on semicircle. Okay, so we call it angle on semicircle because it's that the base is sitting on the diameter. So x is 90 degrees, that's going to be important. Then we have x plus y plus 42 is equal to 180 because they're angles in a triangle. So that means y plus 90 plus 42 equals 180, which means that y is, and I take those away from 180, and I get that y is 48 degrees. And lastly, y plus z equals 90, and that's because of the tangent. So I know that y is 48, so 48 plus z equals 90, which means that z is 90 minus 48, which is 42 degrees. Okay, so once we know all of these rules off fairly well, then you'll find that a lot of the questions use the same rules and use them in the same way. So that one of the angle and semicircle came up in nearly every question that we did. And the idea of using the radius comes up in a lot of questions. So we saw that in this example here. So using the radius and using that to find isosceles triangles, that comes up quite a lot. The last one then was that the tangent is perpendicular to the radius, which means that we get an angle of 90 degrees there, and we use that then in this one to find the value of z. So really across all of these, it's making sure that we're happy with those rules, that we know them well enough to be able to use them. And we saw even here Pythagoras being pulled in as well. So there's different, you can be asked to use all these different rules and all these different points and not just the ones related to geometry. So obviously it's being ready to use those as well. And then lastly, I suppose it's making sure that all your answers are valid and can be used and can be actual answers. So yeah, really it's just, I suppose, making sure just that you're happy with those rules and that you can Use them and state the rule that you're using as well, as we've done there. So writing down what is each rule, where is it coming from, how is that clear to you? So knowing there that x was 90, that's because of that one that we call angle on a semicircle. So just that you're always listing those rules out when you're using them as well.